A system providing these characteristics had been designed and was being tested on the 1/20th scale model. A focusing control ring around the lower periphery of the vehicle replaced the spoiler control and deflected the jet to provide both control and forward thrust. Static test using steam provided flow visualization of focusing ring control operation both in free air and near the ground. Static and forward flight force tests were performed in the Avro wind tunnel, and flow visualization tests were also performed in the forward flight configuration. After successful completion of model tests, the system was installed in both vehicles. A further period of development in the static rig was required to check the characteristics of the new control system before flying continued. Most of the effort during this period was devoted to achieving a system in which the power required to operate the focusing control ring was compatible with the pneumatic power available from pilot and gyro stabilizer inputs. Tethered and free flights which followed were directed toward increasing the stability of the vehicle in the ground cushion and increasing the stable height of the ground cushion. Development of the new control system resulted in a marked improvement in attitude stability, control sense, and response rate. At a height of 3 feet and at forward speeds up to 20 knots, the vehicle no longer displayed the previous tendency to oscillate after pilot inputs, and short, stable flights with hands off were now possible. The height at which the ground cushion tends to become unstable, now known as the critical height, was found to occur at the point where the simple annular jet formed near the ground changes to the focus jet formed at increased height. Any change of attitude with the aircraft at this critical height causes the jet to become focused on the upgoing edge while remaining unfocused on the downgoing edge with resultant hysteresis. An additional, more powerful central jet was added to improve ground cushion stability. It was found, however, that an increase in ground cushion stability was accompanied by a decrease in control power, and the final configuration represented a compromise between the two requirements. tests were also performed to establish the stabilizing effect of the gyro stabilizer, and it was determined that signals resulting from small changes of attitude were being lost due to system friction and control ring hinge moment. It was apparent at this point that some form of assist was required to transmit stabilizing signals from the gyro to the control ring, and design of a pneumatic booster was commenced. At Ames Research Center, the first vehicle was now ready for installation in the 40 by 80 foot subsonic tunnel. Here, tests would be performed to determine the transition trajectory from hovering both in the ground cushion and in free air. These tests were all performed using the focusing ring control system, which had resulted in the most successful free flights on the vehicle at the Avro test facility. The variable mount permitted testing to be carried out at heights up to 12 feet. Flight tests on the second vehicle were discontinued to permit introduction of the pneumatic control boost system. This involved the introduction of 6 sensing nozzles at the base of the central control shaft to monitor 6 pneumatic actuators mechanically connected to the control ring. The base of the shaft was now secured by a flexure, and only a small travel was required to transmit gyro-stabilizing signals to the actuators operating the control ring. Functional and frequency response tests were carried out with the pneumatic system pressurized from an external supply. A variable speed mechanical shaker was used to excite the control column, and measurements of control ring motion were made using potentiometers connected to a continuous trace recorder. Subsequently, the tests were repeated with engines operating and the system pressurized by engine bleed air. Tethered tests were performed to permit final checking of the power-boosted control system before free flying was resumed. Flights with the pneumatically boosted control system showed a marked improvement over the previous configuration. Stabilizing signals from the gyro were now quite apparent. The pilot reported that the feel of the aircraft was better with the new system, and that precise positioning without excessive effort was now possible. In summary, development of the vehicle resulted in a gradual improvement from the relatively unstable first flight requiring rapid pilot inputs, through various applications of the spoiler control system, which was abandoned due to lift loss with control application, and ultimately to the introduction of the focusing control ring, which resulted in the most significant improvement to date. In the most recent configuration, with the addition of the pneumatic control boost, the vehicle displayed stable flight characteristics at a height of 3 feet and at speeds up to 30 knots. The wind tunnel test data showed, however, that the focusing ring control, though it had been developed for satisfactory hovering,